We're going to look at solving rational equations and rational inequalities today. In solving rational equations, you're going to work with these differently than we did with rational expressions at the beginning of the chapter. So if there's an equal sign or an inequality sign, you can do what we're doing today. But if there's no equal sign or inequality sign, then you can only multiply by special forms of 1 like we did at the beginning of the chapter. The first thing you want to do is to find your least common multiple, or least common multiple of the denominators, or your least common denominator. To do that, you need to go ahead and factor each denominator. 24 factors into a 3 times a 2 cubed, because you know it's 3 times 8. Second one does not really factor. The last one, a 4, factors into a 2 squared. Remember, in trying to find your LCD, you write all the different things down that occur in the bottom. A 3, a 2, a 3x minus, or a 3 minus x, and then you have a 2 showing up. So you just write all those things down, and then remember, if you have a choice on exponents, like we do on the 2's, of a 2 squared or a 2 cubed, you always need to take the higher exponent. Once you have your least common denominator figured out, you really take your least common denominator and you multiply both sides of your equation by that. Because remember, with an equation, you can do the same thing to each side and it does not affect your answer. So the first fraction, I'm going to multiply by my LCD. Second fraction, I'm going to multiply by my LCD. And then on the right side of the equal sign, I'm going to multiply it by my LCD. Then you can go ahead and start crossing things out that are on the same on the top and the bottom. If you are doing it correctly, all your denominators should end up dropping out. Notice that it's only a 2 squared on the bottom, there's a 2 cubed on the top, so it simplifies down to a 2 to the first. So if you're doing it correctly, all your denominators should drop out, and that's what we were showing here. So then you want to work with what you have left. You're left with a 5 times the parentheses with no denominator other than 1, plus, and then you have a 2 times a 2 cubed times a 3 with no parentheses, your equal sign, and then you just have your 2 times your 3 times your parentheses with no denominator. And most people will find this red equation easier to go ahead and solve. So we could distribute through the 5, figure that out, equals distribute through your 6. Then we can go ahead and solve this by combining our like terms on the left side. Notice we could go ahead and add a 6x to both sides, and we could subtract 63 from both sides, and we get x to be a negative 45. X being negative 45 ends up being your answer. However, you do want to go ahead and check one thing. Since we are dealing with variables in the denominator, you want to go ahead and make sure that you never end up dividing by 0. So will your answer, 45, ever cause any of your denominators here to be 0? Obviously not in the first one because there's no variables. And 3 minus a negative 45 is not 0. And obviously not here because there's no variables. So it does work. Sometimes you'll get an answer that causes you to get a 0 on the bottom, and we would refer to that as an extraneous solution, and you would not include that in your final answer. So let's go ahead and do that here. The first thing you need to do is to factor your denominators. The first denominator does not factor, but you'll notice the second denominator is really differences of squares, and that's what we have listed down here. Then the last one is really over 1, so we don't really need to write anything there. So you got to list all the different things that are occurring in your denominators. You have a p plus 1 that shows up in a couple spots, and then you have a p minus 1. But just because p plus 1 shows up in more than one spot doesn't mean you do anything different with it. Well, I guess I see I got an extra parenthesis there. Sorry about that. Then you want to multiply everything by your LCD, keeping in mind that this right here is really over 1. So you got to multiply the first fraction by that. Then on the other side of the equal sign, your first fraction on the right side, you got to multiply by your LCD. And then you'd want to go ahead and take your last fraction, which is really p over 1 times your LCD. Then once again, things should drop out. Your denominator here drops out. Here, this drops out with that. And your p plus 1's also drop. If you're doing this correctly, you should always get your denominators to drop out. So then we can work with what's left. What's left here, you have your p squared minus p plus 1 all times your p minus 1. Equal sign. You have your p squared minus 7. And then over here, nothing drops, so it's a p, and then your two parentheses. Now all we have to do is go ahead and multiply this out. You're going to have to take your p times each one of these three. Then you have to come back and take a negative 1 times each one of these three. When you do that and combine all your like terms, okay, I guess I didn't combine my like terms, but you will get this right here when you multiply it out. Equals, we don't need our parentheses here. Over here, remember this, if you FOIL these two to p squared minus 1, then you can go ahead and distribute through your p to your p squared minus 1, and we get this here. Now, notice at this point, we have a p cubed on each side. Subtract a p cubed from each side, and they drop out. Well, here we have a negative p squared and a negative p squared. So if we add our negative p squared, which is a negative 2p squared, if we add a p squared, 2p squared to the both sides, we get this on the right side. Here we have a p and a p, which is 2p, and it's positive, so we got to get to the other side, so we need to subtract a 2p from both sides. And your negative p minus a p, 2p, your negative p minus your 2p is a negative 3p. Take your 1 and bring it over. So you'd have to add 1, and add 1 under negative 7 is this. Now you'd want to continue to solve this quadratic. Since I like to deal with smaller numbers and I notice everything is divisible by 3, I'll divide everything by 3 by factoring it out here. Then I want to go ahead and factor my parentheses into two parentheses, basically the unfoiling, and I get a p minus 2 and a p plus 2. Now you want to go ahead, and since you have it written as several things multiplied together, all equal to 0, the only way to get 0 when you multiply is if one of the parentheses is 0. You'll notice your 3 in front's never 0, there's no variables there. This parenthesis here, when is that equal to 0? At 2. When is this parenthesis equal to 0? That's negative 1. So these are our answers of a 2 and a negative 1. However, keep in mind up here, if you plug a 2 in here, it doesn't cause you to divide by 0 because you get a 3. And a 2 minus 1 is 1, and a 2 plus 1 is 3. So your denominators don't become 0 when you plug in the 2. But if you try your negative 1, a negative 1 plus p, a negative 1 plus 1 is 0, so it causes you to divide by 0 here. It would also cause this one here to divide by 0. So you are not able to use your negative 1 since you are dividing by 0. So your only answer is the 2. So we'll just continue on here. Factor your denominators to find your LCD. List all the different things that are occurring in your denominators, and you get a common denominator of this. So we now need to go ahead and multiply each one of our fractions down here by our LCD, which is really over 1. So we multiply the first fraction by that. On the other side of the equal sign, we multiply this fraction by that. And then we multiply this fraction by that. Then we want to simplify. You'll notice these drop out because they're the same top and bottom. And once again, all our denominators drop out. And that should always happen if you're doing it correctly. So here you're left with just your 4 or x plus 4. Your equals, you're only left with your 2x plus 1. And then you're left with your 2 times your parentheses of an x minus 2. Get rid of your parentheses by distributing through your 2. Then we can go ahead and combine any like terms we happen to have. Your 2x and your 2x is 4x, your plus 1 and your minus 4 is minus 3. Then we can go ahead and subtract an x from both sides, so we get a 3x. Add a 3 to both sides to get your x's by itself, we get a 7. Divide and we get 7/3. Once again, this is going to be your answer, but you got to make sure you check it to make sure you don't end up dividing by 0. If you put 7/3 and subtract 2, you don't get 0. Or 7/3 plus 4, you don't get 0. So we don't have to be concerned about dividing by 0. Now we're going to look at solving inequalities that are rational. They're very similar, however you got to do a couple extra things. You got to look at what causes the bottom to be 0. So what will cause any of your denominators to be 0? That happens to be when s is 0. You find your LCD. In this case, you have a 3 squared, and an s, so it's a 3 squared times s, or a 9s. Multiply each one of your fractions by 0, or not by your common denominator of 9s. Then you want to go ahead and do some simplifying. Your s's drop. This 3 drops makes this 9 a 3. Your 9s's here drop. And your 3 here drops, making this a 3. And then you want to look at what's left. You have your 3 here, plus the 9s's drop. You just have a 2. Over here, you have your 3s and a 2. And so you get 5 is equal to 6s. Divide by 6. So, what causes your denominator to be 0, and what you get from solving the equivalent equation are referred to as your critical points. So that's what caused your original problem to have a 0 on the bottom. This is what we got by solving it as an equation. You want to put those two numbers on a number line, and then all you want to do is check a number in each region to see what works. Here, you've got to try a number to the left of 0, say a -1. Plug a -1 here, a -1 here, and if needed, use your calculator. And you want to know, is this going to be a true statement when you do that? And in this case, it ends up being true. Then you could try a number in between, say a half. Try a half, plugging it in here in each spot, see if it's a true statement. It is not a true statement. Doesn't work. And then you try a number over here, say 1. Take 1, plug it in here for your s's, and it ends up being a true statement, so it's going to work. So then you write your inequality. It's going to be two separate inequalities since you're dealing with two totally separate regions. Now we'll go ahead and do this one here. We're going to solve the equivalent equation, but you want to figure out what causes the bottom to be 0, and in this case it's whenever x is 0. Now we got to find your LCD. So you're going to multiply everything by 5x. Then you're going to cross out your what's the same on the top and the bottom. Then you're going to write what you have left. You're only left with a 5 plus just a 3 times 5. And then over here you're left with a 2x. Okay, sorry about that. I said a 3 times 5, but the 5 dropped with the bottom one, so it's just a 3 here. So you get 8 on the left equaling a 4x. You go ahead and divide your 8 by 2, and you get 4. So your critical points are what you get from solving it and what causes you to divide by 0. You put those on a number line, which we have right here, and then you want to try a number in each region. Put a negative into your original problem here. Could say a -1, plug it in here and here, and you'll realize it doesn't make it work. Plug in something in between, say 1 for your x's, and it ends up working. Try a number over here, say 5 in for your x's, and it does not work. So you just get this inequality. Since it's got two endpoints, you got to put the 0 down, put your variable in between because you're shading in between, put your 4 down, and it's always less thans.